In this lab, we're going to be using gas laws and stoichiometry to calculate the mass of a piece of magnesium metal. So here's our piece of magnesium metal, and it has a known mass, and your job is going to be to calculate what that mass would be, again using gas laws and stoichiometry. So we're going to react the piece of magnesium metal with hydrochloric acid, and we're going to produce hydrogen gas as one of our byproducts. And the hydrogen gas is going to be collected in what's called a Udeometer. And a Udeometer is essentially a long, thin tube that has numbers on it so we can record volumes. So we take a look at our Udeometer. It starts with 0 at the bottom, really, but at the top. And then there are 2 milliliter increments. So we've got 2, 4, 6, 8, 10. In between each 2 milliliters is a line, which would be 1 milliliter. And then in between each 1 milliliter increment, there are 5 lines. So each line represents 2/10 of a milliliter. And what we're going to do is react the magnesium metal and the hydrochloric acid. We're going to produce hydrogen gas, and we're going to collect that gas in this Udeometer by a process called displacement of water. So what I'm going to do first is I'm going to take my piece of magnesium metal, and I'm just going to put it in a bucket of water. It sink to the bottom. I'm going to take the Udeometer, and I'm first going to add some hydrochloric acid. It's going to be in excess. I just need to make sure that I have more hydrochloric acid than I need to react with all of my magnesium metal. Next, I'm going to add some water to my Udeometer, and I'm going to add water to the Udeometer until I fill it all the way to the top and actually to overflowing, because I'm going to take this Udeometer and invert it or flip it upside down, and I don't want to have any air bubbles in my Udeometer when I do that. So I'm going to put my thumb over the top, I'm going to flip it over, and then I'm just going to cover my piece of magnesium with my Udeometer. And I'm actually going to clamp it up here so that I don't have to hold it, so that we can kind of take a look at what's going on. So if we look up a little bit closer, we're going to see that the hydrochloric acid, it's moving its way down the Udeometer. It's more viscous and more dense, so it's sinking down in the water. And eventually it's going to get to the point where it hits the magnesium in the bottom of the bucket, and the reaction is going to take place. And what we're going to see is hydrogen gas being generated. So we're starting to see some bubbles that are being produced because of our reaction. The hydrogen gas is less dense than the water, so it's going to start to float up to the top of our Udeometer, and it's going to start to displace the water in our Udeometer. So if we take a look, we're starting to get an air bubble in the top of that Udeometer, and that air bubble contains some water vapor, but mostly the hydrogen gas that we're generating when the magnesium and the hydrochloric acid react with each other. So as that hydrochloric acid hits the magnesium more and more, the reaction is going to go faster and faster, and eventually we're going to see that our Udeometer is going to be starting to fill up with gas. Again, that process is going to increase in rate, and we want to measure the volume of the hydrogen gas that we produced. Okay, so once that magnesium comes in contact with more concentrated hydrochloric acid, we produce more and more hydrogen gas, and that displaces the water out of the Udeometer. And what we're eventually going to want to do is record the volume of hydrogen gas that we produced. So now that magnesium has floated up to the top because it's kind of coated with hydrochloric acid and producing hydrogen gas, which floats up. And the hydrogen gas is displacing the water in the Udeometer. And once the reaction's complete, we won't see any more bubbles being produced. And what we want to do when we're done is we want to record what the volume of the hydrogen gas is that we produced. So we'll move in a little bit closer again, see if we can get that number. We'll know the reaction is complete when we don't see that magnesium anymore and we don't see any more gas being generated. And I'm actually going to take a darker index card and put it in as a background so that we can see where that bubble is. So again, what's happening is the magnesium reacted with the hydrochloric acid. It produced hydrogen gas. The hydrogen gas floated up to the top of our Udeometer. It displaced the water in the Udeometer. And once the reaction is complete, we can measure the volume of hydrogen gas that we generated. So it looks like we're about done. Again, we're going to kind of be reading down in this Udeometer, so it's between 82 and 83 milliliters. And it looks like it's a little bit closer to the 82 than the 83. So I would say 82 point, well, actually it's going up just a little bit because the pressure's equalizing. Let's give it a second to equalize. So we've got actually bottom of the meniscus, 81.80 milliliters. Now, we can take that information and do two things with it. We can use our ideal gas law to figure out the number of moles of hydrogen gas that was produced, then do our stoichiometry to find the moles and then the grams of magnesium that we started out with. Or we can take that volume and correct it to standard temperature and pressure. Use 22.4 liters equals 1 mole and figure out the moles of hydrogen gas that was produced. And then use our stoichiometry to figure out our mass of magnesium. So do those calculations and then we'll go over them.